Hi there. What we're going to be working on in this video is linear equations. So just want to remind you, a linear equation is basically an equation of a line. And part of what we're going to deal with the line is the slope or the steepness of the line. So the slope of the line is defined by the vertical change, in y, divided by the horizontal change in x, also known as the rise over the run. So if we look at our graph here, what we can simply do is count how many units up we have to go from one point to the other, and then how many units over to actually get from that one point to the other. So starting here, I can see we have to rise up. So I'm going to write this down. Slope equals 1 unit up, and then 1, 2, 3, 4 to the right. So the slope of this line is 1 over 4. Now, if we kept doing that, you'd see we'd keep going to solid points here. So we'd go up 1 and then right, 1, 2, 3, 4. So that's the slope of this line. When we have that on a graph, it's very easy because we can just count the boxes, and that will give us the slope. I do just want to caution you that if you're counting boxes here, make sure that your fraction is simplified. Okay, make sure you have a fraction that is simplified. Okay, so you'll do those problems on your own. So when we're not given a graph, we have to calculate our slope using the points that are given. So here's my example. Find the slope of a line that passes through these 2 points. And here is the equation that we will use. So the first thing you might want to do, at least what I do, is I kind of give myself the framework for this problem. So I write slope equals, and I put my 2 subtractions in the under and over the fraction bar. Now, the way I do this, you could go ahead and label your points and drop them in, but how I do it is I say put any x value underneath its partner y value. So I would put 2 underneath the -5. Okay, and then I will put the 6 underneath the 3, under the 3. And then using order of operations, we know we have to simplify the numerator and then simplify the denominator. So -5 minus 3 gives us -8. 2 minus 6 gives us -4. And then we have to reduce this as much as possible. So personally, I would say negative over a negative gives us a positive. 8 divided by 4 is 2. That's how I prefer to do it. Now, I'm going to go through this a second way, and if it confuses you, just don't even worry about it. You can kind of skip over this. But what some people like to do is, I'm just going to erase this. They like to label the points as x1, y1, x2, y2, and it's totally fine to do that. So I'm going to call this x sub 1, and I'm going to call this y sub 1. And I'll label this point x sub 2 and y sub 2. The reason why people like to do this is because now when you give yourself your fraction, you can kind of follow this guide. So you'll see x sub 1 would go here. Y sub 1 would go right above it. X sub 2 would go here. Y sub 2 would go right above it. Now you might notice my points landed in the opposite spot as the last time, but it's actually going to turn out to be the same answer. 3 plus 5 is 8. 6 minus 2 is 4. And when we reduce that, we still get a slope of 2. So it is totally up to you if you want to label your points like this and then drop them into the formula. That totally works. If you want to use the other method where I put any x value under the y value, that will work as well. Okay, so that is up to you. So you're going to go ahead and do these 3 problems. And the last thing that you're going to do is we're going to be graphing a line when it's in slope-intercept form. So slope-intercept form, you've seen this before, y equals mx plus b. So what we always do first is we plot the y-intercept on the y-axis. This right here, the b value, is the y-intercept. So I'm going to go and I'm going to look at it right now. If you look at this example, y equals negative 2x minus 3, negative 3 is our y-intercept. So we go over to our y-axis and we go down 1, 2, 3, and we put a little point there. Step number 2, from the y-intercept, we use the slope to count the rise and run. So you should remember that the slope is the number in front of the x, right? The coefficient of the x. So we have a slope of negative 2. Now we need to make that into a fraction, so we're going to put it over 1. What that tells us to do is from this y-intercept, go down 2 units and go over to the right 1. In other words, our rise was negative 2, our run was 1. I like to do that a few times. Maybe go in the opposite direction as well. So instead of down and to the right, I'll go up 2 and to the left. You could do this all day. These points would all be making a line. And then we go ahead and draw a line through those points. And that is a graph of the equation y equals negative 2x minus 3. So I just want to bring you down here because these two problems are written in slope-intercept form. So is this one right here. This one is not. Number 52 needs some work. So I'm going to bring it right down here. We have 3x minus 5y equals 10. What we have to do is we have to solve for y. So first thing we're going to do is move over the x term. Well, this 3x is positive, so to move it to the left, to the other side, we're going to subtract it. We are left with negative 5y equals, and we put that x term first and then the plus 10. Because remember, we're trying to get it into y equals something times x plus the y-intercept. So now again, what do we have to do to get y alone? We will divide everything by negative 5. So in dividing that by negative 5, this cancels out and we're left with y equals a negative over a negative becomes a positive 3/5 x. 10 divided by negative 5 gives us minus 2. So now you should be able to graph that. 3/5 of x minus 2. Now that it's in slope-intercept form. Okay? Have a wonderful day, everybody.